Well, greeting everyone. Today we're going to do a presentation for marketing campaign effectiveness using the complete journey data set. Our group consists of AL-RAWDHI, Devesh, me, AIMAN, Anis, and ARIQ. So that we will start with exploring data analysis. So before we explore our data, we need to prepare the data. So we need to turn the raw data into insight. So the goal of this data preparation is to transform the massive raw source into high quality analysis ready data. So the process when to prepare the data is by cleaning, organization, and merging data to ensure accuracy. And the impact of this process is can provide an essential foundation for our report BI and machine learning. So the table that we use is transaction, product, demographic, campaign education, coupon, and coupon redemption. So next, so when we prepare, we need to data cleaning and we need pre-process the data. So the goal for this to refine the raw data into high quality analytic data set. So few of method that we use is data conversion. We transform one of the column, one of the column, the transition timestamp from date format to date format for time series analysis. And we also need to do a data set merging. So join transaction column with product and demographic for comprehensive customer behavior analysis. And also we need to link to campaign, merge campaign with campaign description. These two tables to associate household with campaign types. And also how do we handle the missing value? We do like a product for category and coupon validation by implementing dynamic column detection, conditional logic, and try catch array handling. So next is what we need to make an assumption also. So defining the rule of engagement, like I said, a basic rule for consistent measurement. So for the baseline sales are calculated from household that never received any campaign. Campaign effectiveness measured by sales generated during the campaign period. Attribution window, coupon nation are linked, transition within 7 days. And there's a few customer segmentation, high, medium, and low value. Top 20% spending is high, middle 30% spending is medium, and bottom 50% is low. And the score, the effectiveness score, we need how to calculate is sell per household multiplied by transaction per household. So next is the key visualization that we have made from the data. So there's a few chart that appear. There's a first chart is campaign type effectiveness score. As we can see, there's a type A is the most effective score, and also beside the next chart is average daily sale, baseline beside campaign period. This might be quite the same value, but actually if we did dive the value, you can see that campaign was slightly higher compared to baseline. So next chart that available is campaign ID 18 is the most highest, and we can see type A dominate the top 10 sales, and top 10 most frequently purchased item. As you can see, fluid milk product is quite high because of the aggregation, and the second top is tropical fruit. And yep. So next chart that says top campaign by coupon redemption. As you can see, campaign 13 is the most highest, and also the second closer is campaign ID 18 had the most high total redemption around 800. And also for top 15 product categories by total sale, it goes because there's aggregation, there's quite high total sale around more than $600. So next is customer spending segment. There's a box plot. There's a most highest is high value. There's a high median compared to the low and medium. And as you can see, there's a lot of outlier for the high value. As you can 25,250 to 25,000 total spending. That's the most highest outlier. And transaction count by day of weeks. As you can see, Sunday is the most transaction has been made by people. And next. As this campaign performances with household reach, as you can see, the most upper quarter is the type A, is the most total sale and number of household spending, and type C the down there, and daily set time over time. There's a lowest that the middle one. As you can see, the most peak is the Jan 2018. Okay, from here, there's a few insight recommendation. Campaign performer type A is the winner, the most top campaign, and the top star is the campaign 18 with the benchmark success 533K, and the impact we can receive in marketing drive and measurable 0.56 lift in average transaction value. And purchasing behavior, the high velocity item is tropical fruit, fluid milk, and the tertiary profile is high volume of low cost item with median $2 and average of $3.30. And this is successful engaged 1,046,464 household across 68K unique product. And coupon segment value has a redemption leave of tertiary coupon spend 5% more than those without the coupon. And retention, we can see with high value segment show loyalty for up to 365 days with top spender reaching 24K thousand dollars. From here we can recommend is budget shift. We can relocate fund from type A, and also we can replicate the campaign 18 models. And smart bundling, we can bundle the fruit and dairy to a fruit and dairy combo promotion to capture high velocity item. And also, last recommendation, you can position targeting by last personal premium offer specifically for the top 20% for the high value segment. That's all about the value, and I want to pass to Devesh. Ari.
Okay, so I'll explain about multi-dimensional modeling, which is what we did after EDA. So this is the star schema that we got. We referred to the ARD that was provided. So this star schema is actually designed for sales performance analysis. And the fact table, which is sales fact, it captures sales amount and quantity at the transaction level, while the surrounding dimensions allow analysis by product, promotion, household, and time. So we specifically emphasize the time dimension, which follows the required hierarchy from month down to morning, afternoon, and night. And this is derived from transaction timestamps. This is to allow management to analyze sales trends at both high and very granular time levels. Next, I'll pass to Divesh.
Okay, so after the star schemas were created, I extracted the CSV files according to the star schema, which is the sales, product, time, and household, which was then transformed using Python and Excel to clean it, and then it was then loaded to Tableau using live charts. Next. And after we have loaded the data into Tableau, these were the visualizations that we got for sales. For the first one, we have the one-dimensional, where we measure the single metric, which is the sales amount, against the time of day. So from there, what we can see is that in the afternoon, it makes the highest sale, which is 160,000, followed by night and then morning. And then we have the two-dimensional visualization, where we intersect two categories together, which is the product category and mine. So the heat map uses blue intensity to show hotspot of activities of the product throughout the year. So as in this, we can see that beef stays popular throughout the whole year. We have the three-dimensional visualization, where we intersect product and campaign, but then we add the time of the day as the third layer as a slicer. So here we can see that while standard prices, they derive the most sales, but for some items like bags and snacks, they get a very huge boost from type A and type B promotions.
Okay, thank you, Dev. So moving on to how we define churn in the project. So first is the threshold and the rules. So first we had to establish a cutoff point. We looked at the transaction timeline and set a threshold at week 50. If a household last recorded purchase their maximum week occurred before week 50, we label them as having churn. Essentially, if they stop buying before that date, they are considered as a lost customer. Second, data integrity. However, simply having the date in our data set posed a problem for machine learning. If we left the maximum week column in the training data, the model will not actually learn anything. It will just cheat by looking at the week number to get the answer. Last thing, Last thing, outcome. To prevent this state leakage, we use the select attributes operate to completely remove the column from the training phase. This was a critical step because it forced our algorithms to look for deeper patterns, like drops in spending volume or transaction frequency, rather than just relying on the calendar date to make a prediction. Next, I will move to Ari.
The next is the model architecture and workflow. So for this workflow, first we need to pull the data from three sources, which is the sales fact tables and two-dimension table, which is the time dimension and transaction dimension. And all of these data sets comes from the data set that we already changed into star schema, and then we join them to make them into one flat data set based on their primary keys, and then the aggregate operator, which we group the data by the household ID, so we can calculate per customer metrics like their total spend and their last purchase week. And then for the general attributes, we create our target variable, which is churn based on the week of purchase. And then the role setting is, well, this operator tells the AI that churn is the specific answer it needs to predict. And then the select attributes is basically used to prevent the model from cheating, because it first forces the model to learn from actual spending behavior instead of just the date. And then we split the data 70 for training, 30 for test, and then we multiply. We use multiply here because we are training multiple kind of algorithm at once. So that's why we use multiply, and then we connect it into three different algorithm, which is naive Bayes, decision tree, and random forest. So we apply each of the model and we add the performance operator. This is just to enhance the result that we get from the predictive analysis, so we can get more insights. Okay, next. So for the result, we first look at the decision tree performance. And the decision tree have an overall accuracy of 83.75, which is quite high compared to others too. And it correctly identified 189 customers who stayed, but it only caught 12 out of the 38 customers who actually churned. And while the accuracy is high, the class recall for churn is only 31.58%. This means that the model is missing nearly 70% of the customer who are leaving us. Next, we move on to naive Bayes performance, which first you will notice that the accuracy is lower at 75.58%. But this table tells a much better business story, because look at the true yes column. Out of 38 people who actually churn, the model correctly flagged 29 of them, and this gives us a class recall of 76.32%, even though it has more false alarms, which is 52 cases where it thought someone would leave, but they said it is most effective model to predicting the churn. And last is the random forest performance. It looked like the best because it has the highest accuracy at 58.42, but the result is very low for the recall, which is 18.42%, which is useless for churn prevention because it ignores the very people we are trying to find. So from this analysis, we select that naive-based performance is better because it can better predict the churn and have a higher class recall, even though it has less accuracy compared to others. Okay, next I pass to Adis.
Okay, so we have done our EDA, modeling, ETL, and analysis. So what we got from that? So what the data tells us is that type A campaigns, they deliver the highest return of investment, and successful campaigns such as campaign 18 can be replicated. Coupon-based promotions increase transaction value, and high-value customers contribute most of the revenue. So based on this, we recommend the CEO to focus on marketing, to focus the marketing spend on high performing campaigns, and also expand effective coupons, as well as using trend prediction to proactively retain valuable customers. So that is all for our group project. Thank you.